In Chapter 2 of the DVD, when I went over ambient lighting, I mentioned that there was a more advanced form of ambient light that we were going to be covering in a future section. And that's what we're going to cover now. In this section of the DVD, we're going to be talking about how to create a shader that simulates global illumination, that is, light coming from everywhere in the environment. And that's what I've got right here in this sample. I've got a teapot and a plane with a shader applied to them that simulates global illumination. Now there's two parts to this effect. One part is called Ambient Occlusion, and what that is basically the model casting shadows on itself. And that's what we're going to talk about in this chapter. And then in the next chapter, we're going to be talking about diffusely convolved cube maps. And that sounds kind of like a scary term, but we're going to go over how to create cube maps which represent light coming in from every direction to light our model. So first of all, what we've got here is a teapot with both a diffusely convolved cube map and an ambient occlusion map applied. Well, let's take a look at just the ambient occlusion map. So I'm going to pull up a brand new material here and apply it to the teapot. Now what you see when I apply a new material is just the standard diffuse model. And I just want you to notice really quick how much more realistic it looks when we've got this global illumination applied. The problem with the standard diffuse model of lighting is you've only got light coming in from one direction. And the way light really works in the real world is it bounces all over the place and comes from everywhere. You know, generally light has a main direction that it's coming from, but it also bounces off of things and comes from every direction. So that's what we're going to try to simulate in these next two chapters. So first of all, what I'm going to do is just turn up global illumination, or self-illumination, sorry, and set it to white. And now we can apply an ambient occlusion map. But instead of just applying it, what I want to do is go through the process of showing you how I set it up. So the first thing that you need when you create an ambient occlusion map is a unique set of UV coordinates. You need your model to be unique, completely uniquely unwrapped. And so what I've done in this stack is I've added an unwrap modifier to my teapot, and I set it to map channel 2. Now this is important because what we want to do is preserve the teapot's original texture coordinates that are on map channel 1 and add a new set on map channel 2. Now let me show you what these look like. Well, first of all, let's go to our original teapot and add another unwrap. And we're going to put this unwrap on map channel 1. Actually, not UVW mapping. I want to add an unwrap modifier on map channel 1. And I'm going to hit edit here. And what I want you to notice is I'll zoom out. And what you can see is that this is our 0 to 1 range right here. And my teapot's UV coordinates go beyond 0 to 1. They're actually going from 0 to 2. And they also overlap each other all over the place. And that's what we want to avoid when we're creating a set of UV coordinates for ambient occlusion. We need the teapot to be unwrapped in a completely unique way. So I'm just going to throw out this modifier, and I want to show you what the unique unwrap looks like. So hit edit on this modifier, and remember this is on map channel 2. So I've laid out my UV coordinates here so that none of them overlap each other. And the other thing that I've done is I've stitched the coordinates together so that there are as few seams as possible. I'm going to move this out of the way and mark this so that it shows the seams. And what you can see is that I have very few seams. I just have one on this side of the teapot, and then just one around the handle, and one on the back side of the base of the handle. And I've tried to hide these seams so they're in kind of less obvious places. And that gives me much better results with our ambient occlusion map. So there's the layout. And now what I'm going to do is render to texture. Let me first come back here to the material panel. I'm going to get rid of this self-illumination, and I'm just going to turn the diffuse color up to white. So now I'm ready to use my render to texture dialog to create an ambient occlusion map. Come under here under rendering and pick render to texture. And I'll pick my teapot. And I'm not going to use projection mapping like I would if I were creating a normal map. What I'm going to do is just come down here to my output type, and you'll notice I already have an ambient occlusion map here. I'm just going to delete this so that I can show you how that process works. In order to have, so I'll click add, and in order to have this ambient occlusion element here, notice how it says MR after it. What that means is that I've got the mental ray renderer enabled. So I'll come up here to renderer and scroll down to the bottom, and where it says assign renderer, what I want to have it set to is mental ray renderer. By default, max is set to the scanline renderer, but if I have the scanline renderer set there, it's not going to allow me to render an ambient occlusion map. So I want to set my max renderer to be mental ray, and then I'll pick the ambient occlusion map and hit add elements. And now I can choose, where I want to save out my ambient occlusion map, and I can choose how big. In this case, I'm going to pick 512. And now these settings here allow me to control the quality of the rendering. And generally, if I want to just do a quick preview render, I can leave these settings as they are. But if I want an ambient occlusion map that doesn't have any graininess and it's nice and smooth, I want to set these settings up to quite a bit more than 16 samples. But for now, I'm just going to leave that on 16, just so we can see what we get. And now I'm going to hit render, and oh wait, let me check one more thing here. We want to set padding. We have padding set to 32, and what this does is it stretches the edge values. Let's go back here to our UV layout. So right here at the edge of our UV chunks, when we have padding set to 32, it stretches the colors out beyond the edge so that we don't get black seams around our map. So I have that set to 32, and I'm just going to go ahead and hit render here and see what we get. And we'll go ahead and overwrite the one that we've got already. And it's going to take a little while, so I'm going to pause the video and come back when it's done. Alright, so my rendering's all done. Let's bring up our material panel again and take a look at what we got. I went ahead and added the ambient occlusion map that we got into this diffuse slot here, and we can take a look at our texture by just clicking View Image. And so here's the image that we rendered out, and you can see that it rendered the lighting of the teapot to this texture. Well, let's go ahead and apply this material to our teapot to see what the results look like. And once again, we need to change our self-illumination to white so that we can allow the ambient occlusion map to do the lighting. And you'll notice that it looks pretty screwy. And the reason that it looks like that is because we have our unwrap for our teapot on map channel 2. And so we actually need to go in here to our map and switch it so it's using map channel 2 instead of map channel 1. So I'm just going to set it to map channel 2. Okay, so you'll see that we get a pretty neat effect. This looks similar to the results that we get when we do global illumination with the mental ray renderer, for example. But you may notice that our results are pretty grainy looking. And as I mentioned before, if I were actually doing a real render, I would want to crank this up so that it was doing a lot more samples and maybe enable final gather so that our results were much more smooth. Well, what I've done is I've gone ahead and made a better version of this, and so we'll go ahead and load that one up. And what I did in this version is I took a lot more samples of the image, and I also took it into Photoshop and added some smart blur to get rid of the graininess. So now we have a teapot that has ambient occlusion on it, and with this map alone, it already starts to look pretty good. But in the next chapter, we're going to talk about how to add that diffusely convolved cube map to also light it with lighting from our environment. Because right now, this ambient occlusion map just represents the teapot as if it were lit completely uniformly with white light from everywhere in the environment. And of course, we know that most objects aren't lit by a completely white environment. So in the next chapter, as I said, we're going to talk about how to use that diffusely convolved cube map to give it some nice variation in the environment lighting. Okay, so that's how to create an ambient occlusion map, but now we need to know how to actually create a shader that will do that ambient occlusion. So let's go ahead and bring up Effects Composer and jump right into that part of the shader writing. So here we are in Effects Composer, and the first thing that we need to do is come down to this section of our header that contains the texture maps. And we've got a diffuse map, a specular map, and a normal map. This is the same shader that we've been working on for the whole DVD. And we need to add another texture slot. So I'm going to go ahead and clone the bit of code that adds our normal map texture, and we'll copy that. And this time, instead of calling it normal map, we're going to come in here and change this to light map, so that instead of normal map values, we're going to be entering light map values. And we want to be sure that we change this label here so that people know that they need to put a light map in this slot. All right, now that brings us to another interesting topic. We unwrapped or added UV coordinates to our teapot on map channel 2. So we need a way to tell Max not to use our first set of UV coordinates, but to actually use the second set for this particular map. And so the way that I'm going to do that is by adding a little bit of extra code in here that looks like this. And I just copied and pasted it here really quick. So what I'm doing is I'm telling it that we want to use map channel 2. And we want map channel 2's values to go into text chord 1. And by text chord 1, what I mean by that is my incoming texture coordinates. So right here I've got text chord 0, and we actually need to come in here and add another text chord unit, and we're going to call this text chord 1, and change the register so that those values are going into the text chord 1 register. Now the problem is when we do this, and we're telling Max to put these values into text chord 1 from map channel 2, we also have to specify these for the rest of the textures. I'm going to go ahead and come up here, and we're going to say in text chord 0, we want the values, the UV values from map channel 1. So I'm going to copy this, and we'll paste it to this one, and also to our diffuse texture. So now Max knows that it's going to send UV coordinates from map channel 1 for the diffuse map, the specular map, and the normal map. But for the light map, we're going to be using the texture coordinates from map channel 2. Now the next thing that we need to do is come in here and add a sampler. So I'm going to copy this normal map sampler, and just like I did with the UI element, I'm going to come down here and paste it, and we're going to call this our light map sampler, and we're going to be sampling from our light map. There we go. I'll hit save. And now in Max, I'm going to come over here and bring up our material panel, and I'm going to grab a DirectX 9 shader, and I'll go ahead and pull up the shader that we're using here, which is Chapter 8 Start. And what you'll notice now is that I have a new light map slot that we can fill in. Let's jump back over to Effects Composer. And the next thing that we need to do, I went ahead and added this new line in here to bring in the text coordinates from map channel 2. But I'm actually not doing anything with those texture coordinates yet. So I need to come in here to the vertex shader and be sure that we pass along those texture coordinates just like we're doing with the first set. So I'm going to add a new line in our vertex shader that says out.textchord1 equals in.textchord1. And we added this new element to our output struct. I need to come up here to our output struct and add that element into the output struct as well. So now I've got text chord and text chord 1. But I need to be careful here because I just copied and pasted it, and both of these elements are using text chord 0 as their output register. So I actually need to change this one to use a register slot that I'm not using yet. I'm going to use text chord 6 because I'm not using it down here. That's a free slot. Okay, so what I'm doing is I'm passing the texture coordinates from text chord and text chord 1 into the vertex shader and then back out. And what that'll do is, like we talked about before, that'll interpolate the texture coordinates across polygons. Now I can come down here to my fragment program and actually sample that light map. So I'm going to copy this line here where I'm sampling from my specular texture and paste it in, and we're going to call this our light map texture, and we're going to sample from our light map sampler, and instead of text chord we're going to use text chord 1. So there we go, we've got our light map. And now that we've sampled our light map texture, all that we need to do is take that sample value and multiply it by our ambient color and color texture. So I'm just going to say ambient color times color texture times light map texture, and that puts our new ambient occlusion map or light map texture into our rendering equation. So let's pull up, let's jump back to Max and see the results of our shader. So I'm going to go ahead and fill these slots in. For our diffuse map, I'm just going to put a clean white texture, and same thing for our specular map, just a flat white texture. For the normal map, I'm going to use a blank normal map, which is basically just this flat blue color. And then for our light map, we're going to add in the ambient occlusion map that we rendered out. And so now we'll go ahead and apply this shader to our teapot. And what we end up with is a really nice looking teapot with our ambient occlusion shader applied. Now let's go back to the material panel, and I want to show you a few things just here really quick. So I've got my ambient color turned up to white. So all we're seeing is just the ambient because I have diffuse and specular color set down to black. But if I want to, what I can do is turn this ambient color down to something like 0.5, and I can combine it with the diffuse and specular color. And what this gives me is the best of both worlds. The problem with the ambient lighting is that it's static. It's kind of baked to the surface of the teapot. But the diffuse lighting can actually change when I move my light source around. So what I've got now is half ambient and half diffuse. And so I'm combining what we talked about before with our dynamic omni lights together with this new ambient occlusion map that I've just created and added to the shader. So I'm blending the really neat look of the ambient occlusion light in with the dynamics of the omni light. Like I said, I can get the best of both worlds. And you can play with the balance of these as well. So I can turn my ambient up a little bit. I can turn my diffuse up a little bit. Just kind of move these up and down until you get the best results. Okay, so that's how to add ambient occlusion into your model. Not a whole lot to it, and pretty simple. Just a few little changes here and there to the shader. What we did is we added an extra text chord channel coming into the shader, and an extra one going out from the vertex shader to the pixel shader. Then we went ahead and added that extra line in the vertex shader. And in the pixel shader, we sampled. And when you sample, of course, you got to be careful that you're using the right texture coordinate to sample. And then we added that, or we multiplied that in with our ambient light equation to get the final results. One thing that I want to mention before we're done with this chapter is that you don't have to use a separate set of UV coordinates. For example, if your game engine requires that your model have just one set of UVs, that's fine as well. But you want to make sure that they're unwrapped uniquely. The reason that I did it this way is because it's kind of nice to be able to apply a tiled pattern or be able to overlap or mirror your UVs in your first channel of UVs and have the second one be completely unique for your ambient occlusion. So anyway, like I said, in the next chapter we're going to talk about how to add diffusely convolved cube maps to your shader so that you can get something other than just pure white light.